Okay, so let's get started. We're going to be taking a look at working with our boost control in this training module. We're going to be looking at an overview of the boost control system, understanding mechanically what's going on between a turbocharger, a wastegate, and a boost control solenoid that we actually program and control virtually through the Motec. We need to understand this relationship so that as we move into the future training tutorials talking about boost control, we understand what's going on mechanically and what we're trying to achieve within manipulation of the boost control solenoid. So let's jump in here and take a look at the areas where we can program our boost control, and then we'll talk about the overview here of what's actually going on and unpack all of this so we understand things conceptually. We're going to move from our field tuning page and go over here into boost targets as well as boost PID. These are going to be the areas where we do our boost control programming. What we'll find is within the Motec programming here, we're going to be sending a pulse width modulated signal to a boost control solenoid that'll manipulate what our wastegate valve is doing, allowing more or less exhaust flow to go through the turbine housing across the turbine wheel and spinning the compressor speed slower or faster to achieve a desired boost pressure. This might sound a little bit confusing. Let's unpack this and go through the overview and go through each component one by one so we understand exactly how this is getting controlled and how we need to hook up our boost control solenoid, whether we're dealing with an internal or external wastegate. So coming up on screen, we're going to find a picture of an engine here. It's a turbocharged engine, and we have a couple components here I want to just do an overview with. We have our exhaust manifold, we have our turbocharger, and our downpipe. Now we'll find that the exhaust manifold is going to funnel the exhaust gas out of the cylinder head. It's going to go into the turbine housing. The turbine housing is going to hold a turbine wheel, and then the turbine wheel is connected on a common shaft to our compressor wheel. As we spin our turbine wheel faster, we're going to find we spin our compressor wheel faster. It's going to generate more and more boost pressure. So we'll find that the exhaust manifold puts the exhaust gas into the turbine housing. That's going to allow the turbine wheel to spin. Any excessive exhaust gas is going to go through the downpipe and then out of the exhaust. So it's a pretty simple system here. Let's take a look at a sliced away view of a turbocharger so we can see this a little bit closer. So we find in this case we have our turbine housing and our compressor housing. That's going to be the turbine housings where the exhaust gas is going to flow into, and then we have our turbine wheel, and any of that exhaust gas that isn't going to be needed, it's going to go through the downpipe, which is connected to the turbine housing. It's going to have a discharge. Now the turbine wheel, as it starts to spin, as we can see, is connected on a common shaft. It has two support bearings, and that's connected to a compressor wheel. On our compressor cover, we'll find we have our inlet. That's going to draw the air into the compressor, and then it's going to actually compress that air, pressurize it, and increase the amount of airflow we essentially have coming out of the discharge of the compressor housing. Now the compressor housing is connected to an intercooler pipe, which is connected to an intercooler, and then another intercooler pipe comes off the intercooler, goes to our throttle body. We bring that additional pressure and flow into our engine. So it's a very simple system. And we're going to find in a situation here, as our engine speed increases, our exhaust mass flow will also increase. That's how much flow we have coming through the exhaust manifold into the turbine housing and then across the turbine wheel. That's naturally going to spin the turbine wheel faster and faster. As the turbine wheel spins faster, the compressor wheel spins faster. As that spins faster, we generate more airflow and more pressure. If we don't regulate how much exhaust mass flow goes into the turbine housing and across the turbine wheel, we will get into an overboost situation very quickly. So this is going to be why we introduce a wastegate valve or wastegate assembly. That's going to regulate and bleed off how much exhaust mass flow and exhaust pressure is going through the turbine housing and across the turbine wheel. And then effectively we'll find that we are regulating the turbine speed, therefore regulating the compressor speed, and therefore regulating the boost pressure. So the wastegate is something we need to understand. Now the next picture coming up on screen is going to be a common internal turbocharger assembly. So there's internally wastegated. There's two different types, internally, externally. We'll talk external a little bit here. The internal wastegate is what's found on most OEM turbo manufacturers, probably from mid-2000s and earlier. Most of the newer turbocharged vehicle are going to be using electronic wastegate control, and that's going to be a little bit different than what we're talking about right now. But let's just focus here on mechanically what's going on with the internal wastegate assembly. So what we'll find here is that the internal wastegate is going to be a little bit different than the external, where if we look at the turbine housing, it's going to have a flapper door on the turbine housing. That flapper door is going to open up and it's going to discharge any of the exhaust mass flow that we don't want going through the housing and going into the turbine wheel and spinning that faster. So we'll find that that little valve will have a swing arm that's going to open and close. Now, if we take a look back here at our assembly, that swing arm is going to be connected to a linkage, and that linkage is connected to a actuator, which is going to be a spring and a diaphragm assembly. And we'll notice on top of that spring and diaphragm assembly, there'll be a little bit of a nipple. That nipple goes to our compressor source, which is going to be our pressure into that assembly. That actuator with the spring inside will have a certain regulated amount of pressure that it's going to move that swing arm open or closed. When the swing arm is closed, we'll generate maximum amount of pressure through the turbine housing and therefore across the turbine wheel, building as much boost as we can. If that actuator opens up, depending on where the travel is, it has full swing open or somewhere halfway, it's going to have a different amount of exhaust mass flow that's going to go bypass across the turbine housing, the turbine wheel. So we'll find the spring pressure inside that wastegate diaphragm assembly will have a certain pressure that it's going to have a full open at. So that could be at 10 pounds, it could be at 20 pounds. That's our base spring pressure, and it will actuate and open up that flapper valve at that rated pressure. So it's a very simple mechanical system. Now, taking a look here, the next schematic or picture we're taking a look, that's going to show our boost control solenoid. That's what we're controlling through the Motec in our programming. This is going to allow us to start to cut off the airflow that would normally, the airflow and pressure that would normally go into the nipple, and that would be the normal pressure reference. So we can take a look here. If we remove the nipple, so we have no vacuum line or pressure line going to that nipple, what you'll find is that the actuator, the actual swing valve, won't open at all. And you'll start to just generate massive overboost conditions, and definitely something not desirable.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.